Hello and welcome to NEET classes. Today I am here to solve chemistry class 12th NCERT problem 2.19. Let me read the problem. A solution containing 30 gram non-volatile solute is in 90 gram water has vapor pressure of 2.8 kilopascals at 298 Kelvin. Further 18 gram of water is then added to the solution and the new vapor pressure becomes 2.9 kilopascal at 298 Kelvin. Calculate molar mass of solute and vapor pressure of water at 298 Kelvin. So here we have a situation that when the solution contains 30 gram of non-volatile solute in 90 gram of water, vapor pressure of solution that time is 2.8 kilopascals at 298 Kelvin. Obviously it will be lower than vapor pressure of pure water at 298 Kelvin. Then 18 gram of water is further added to the solution. 18 gram of volatile component liquid water is added to the solution. What will happen? Vapor pressure of solution will get increased, and in the question it is given that vapor pressure of solution is increased to 2.9 kilopascals from 2.8 kilopascals. But here again value 2.9 kilopascal will be obviously lower than vapor pressure of pure solvent at 298 Kelvin. Now what we have to calculate? We have to calculate vapor pressure of pure water at 298 Kelvin and molar mass of solute, non-volatile solute. So problem is based on concept of relative lowering of vapor pressure, and expression for relative lowering of vapor pressure is this: P01 minus P solution divided by P01 is equal to mole fraction of non-volatile solute Chi2, or I may write P01 minus P solution divided by P01 is equal to N2 divided by N1 plus N2. This is equation A, this is equation B. Both are basic or fundamental equations for relative lowering of vapor pressure, for expressing relative lowering of vapor pressure of solvent or solution, and both, according to both, relative lowering of vapor pressure is equal to mole fraction of non-volatile solute, that is number of moles of non-volatile solute related to total number of moles in solution. But neither I will use this form of equation here, nor I will use this form of equation here, but I will use this form of equation: P01 minus P solution divided by P solution is equal to N2 divided by N1. Now idea is that this I will label equation C. Idea is that I want to make my calculations easy, but there should be no difference in the solution, or there should be no difference in the answer of this problem. How I can minimize my calculations, how I can save my time in order to solve this problem? By reducing number of parameters in the equation. You see here in this equation there is N2 in denominator, but here in this equation there is no N2 in the denominator. So but I will use equation C just to minimize my calculations, just to save my time, and there will be no change in the answer, there will be no change in the solution, because the parameters that are present in equation B are also present in equation C. P01, vapor pressure of pure water. Vapor pressure of solution, vapor pressure of solution, N2, N2, N1, N1. Because because parameters present in both the equations are same, so answer by using equation B or using equation C, I will get same answer. Now number of moles is not given, instead mass is given, so I will express this equation in one more form where I will express number of moles in terms of mass. So equation will be P01 minus P solution divided by P solution is equal to W2 divided by M2 into M1 divided by W1. We know number of moles is equal to ratio of given mass and molar mass for both solute as well as solvent, and by expressing number of moles in terms of ratio of mass, given mass and molar mass, I will end using this equation. This is the actual form of equation. I will label it as equation D. This is the actual form of equation which I will use here in order to solve this problem, and I am driven to use this form of equation because the data given in the question is not in terms of moles but in terms of mass. So I will use equation D in order to solve the problem. Now for situation first, or for solution in situation first, P01, I will substitute the values. P01 minus P solution is given. P solution is 2.8 divided by P solution is 2.8 is equal to W2. W2 is 30 into molar mass of water is 18 divided by molar mass of non-volatile solute. I have to determine M2 I have to determine, multiplied by weight of solvent W1. In situation first, weight of solvent is 90. This I will label as equation 1. Situation 1 is where 30 grams of non-volatile solute is dissolved in only 90 grams of water, and for solution in situation for same solution but situation is different because weight of solvent instead of 90 is in situation 2 weight of solvent is different. P01 minus, this time vapor pressure of solution is increased to 2.9 because weight of volatile component liquid water is increased from 90 to 30 into 18 divided by M2 into, now weight of solvent this time is 90 plus, because question says 18 grams of water are further added, so weight of water this time is 190 plus 18 is 108. This I will label as equation 2. Now I will divide equation first by equation 2. Divide first by 2. Divide first by second. Now what will happen to LHS side? LHS side will become P01 minus 2.8 into 2.9 divided by P naught 1 minus 2.9 into 2.8 is equal to, what will happen to RHS side? In RHS side I will get 13 into 18, 13 into 18 in the numerator, it will get cancelled. M2 will get cancelled. I will get 108 divided by 90. Now on solving I will solve this equation for P01 because molar mass of non-volatile solute got cancelled. On solving P01, which is vapor pressure of pure water, P0 water at 298 Kelvin, which obviously will be greater than 2.8 or 2.9. It comes equal to, I have made my calculations, it comes equal to 3.53 kilopascals. This is answer to part second of this question, in which I had to find vapor pressure of pure water at 293 Kelvin, and value, you must remember that vapor pressure of water in pure state at 298 Kelvin is 353 kilopascals. Vapor pressure of water at 298 Kelvin, room temperature, is 3.53 kilopascals. And now I will substitute this value either in equation first or in equation second. Substitute P01 is equal to 3.53 kilopascal in first or second, in equation first or in equation second. In first, I will write P01, instead of P01, I have to substitute its value, that is 3.53 minus 2.9 divided by 2.9 into, okay, I substituted it in equation second. I can substitute in equation first or in equation second. In equation second, 3.53 minus 2.9 divided by 2.9 into is equal to 30 into 18 divided by M2 into 108. And I will solve this equation for M2. Rest all parameters are known, only M2 is unknown, so I will solve this equation for M2, and I have made my calculations. Value of M2 comes equal to 23 grams. So molar mass of non-volatile solute is 23 grams, and I guess it is sodium, because metallic sodium has 23 molecular, sodium has 23 gram atomic mass. 23 gram atomic mass of sodium is 23 grams. Though I need not to name the solute or identify the solute, I have to only determine the molecular mass of solute, which comes equal to 23 grams. It cannot be sodium because I have to determine molecular mass, and sodium has atomic mass. Just write answer. Molecular mass of non-volatile solute is 23 grams. Now let me recall. Problem was based on relative lowering of vapor pressure. In situation first, solution had 30 grams of non-volatile solute in 90 grams of water. That time vapor pressure of solution was 2.8 kilopascal, obviously lower than vapor pressure of pure solvent. And in situation second, solution had same non-volatile solute, same mass of non-volatile solute 30 grams, but in 108 grams of water, because this time 18 grams of water was further added. And this time, because the mass of volatile component liquid water was increased from 90 to 108, vapor pressure of solution got increased from 2.8 to 2.9, but still it will be less than vapor pressure of water at 298 Kelvin due to lowering of vapor pressure. So I got to know that problem is based on relative lowering of vapor pressure, and basic or fundamental equation of relative lowering of vapor pressure is this, which says that relative lowering of vapor pressure depends on mole fraction of non-volatile solute, that is number of moles of non-volatile solute relative to total number of moles present in solution, confirming it is a colligative property. But I said that I want to minimize my calculations, I want to save my time, and for that instead of equation B I will use equation C, where in parameters are same as the parameters are as they are in equation B. So answer I will get same whether I will use equation B or equation C, but using equation C will allow me to have less calculations so as to save time. And I expressed moles in terms of given mass and molar mass, because data given was not in moles but in given mass and molar mass. From using this, I said I will, this is the actual form of equation D I will use here, and I substituted values of given parameters in equation D in situation first, wherein 90 gram of water was used, and in situation second, wherein 108 grams of water was given. Then I divided first by second. By doing this, idea was to cancel molecular mass of non-volatile solute, and I got this equation in which there is only one parameter, that is vapor pressure of pure solvent, that is water at 298 Kelvin, and on solving this I got vapor pressure of water is 3.53 kilopascal, obviously greater than 2.8 or 2.9 vapor pressure of solution containing non-volatile solute. And data here confirms that lowering of vapor pressure occurs because of addition of non-volatile solute to solvent. And then I substituted vapor pressure of water equal to 3.53 kilopascal in equation second. Idea is that by substituting value of vapor pressure of water in equation first or in equation second, I can solve the rest equation for M2, and after solving I got molecular mass of non-volatile solute is 23 grams. Class 12 students, this is the problem I have got for you today. See you day after tomorrow, as tomorrow is reserved for class 11 students. Take good care of yourself. Allah Hafiz.